We are looking at the negative and zero exponent rules today. So first of all, we're going to consider a to the exponent of 5 divided by a to the exponent of 5. If we follow our exponent rules for division from our last video, we know that we would keep our base the same, and the exponent rule says we would just subtract our exponents. So if we have 5 take away 5, we're going to get a to the exponent of 0. So the question is, what does that actually mean? Well, let's think about it over here. If I have a to the exponent of 5 divided by a to the exponent of 5, we know from previous work with division, any number divided by itself will always just equal 1. It goes in one time. So for example, if we had 7 divided by 7, it would equal 1. If we had 54 divided by 54, the answer is 1. If we have negative 233 divided by negative 233, the answer is 1. So that comes to a conclusion here that anything to the exponent of 0 has to always equal 1. And that's really our zero exponent rule. So any base to the exponent of 0 will always equal 1. Now, we need to be careful and consider what our base is when we're doing those kinds of evaluations. And I didn't put in any room here for much room here for examples, but I'm just going to do an example or two here. For example, if I have 3 to the exponent of 0, the answer is equal to 1. If I had, as an example, negative 3 in brackets to the exponent of 0, that will equal 1. Another example here, if I had negative 3 to the exponent of 0, this time without brackets, the base in this case is only the 3, and that is going to equal negative, and then 3 to the 0 is 1. So just be careful of those ones. If I had a 7x to the exponent of 0, my base with the exponent of 0, the base is actually just the x. So the x to the 0 is a 1. So I'm going to end up with 7 times the 1, which is equal to 7. So just a few examples there to help you through understanding how that actually works. All right, our next part, which leads us into our negative exponent rule, if we have a to the exponent of 3 divided by a to the exponent of 5, the rule for dividing is that we keep our base the same and we're going to subtract those exponents. So 3 take away 5 is actually equal to negative 2. So now we get this negative exponent that we have to worry about and work with. So I'm going to look at that example again, but this time in a little different fashion here. I could write a to the 3 divided by a to the 5 with division as a fraction. So instead of writing the line and 2 dots for the divide, I'm writing it as a fraction. And then what I'm going to do is take that a to the 3 and write it out in its expanded form. That really means a times a times a. And on the bottom, we're going to have 5 factors of a. So a times a times a times a times a. And then we're going to pair things up and reduce them. So for example, I know that a divided by a, that's just going to end up equaling 1. And I could take another pair of a divided by a, and that equals 1. And I can match up another pair, a divided by a, that's going to equal 1. And what I'm left with, on the top, I have a 1 times 1 times 1, which is just equal to 1. And on the bottom, I have 1 times 1 times 1 times a, or a to the exponent of 2. So in the end here, it looks like a to the exponent negative 2 is equivalent to 1 divided by a to the exponent positive 2. So it looks like that negative exponent just tells us to take the reciprocal of the base originally being a, so it becomes 1 over a, and then my exponent becomes a positive value. So let's take a look at that further on our next slide. All right, consider 1 over a to the exponent negative 2. What we're going to do with that, that's the same thing as 1 divided by, so that division fraction line is really the line and 2 dots, 1 divided by a to the exponent negative 2. So I'm just rewriting it in another form. That's going to equal 1 divided by, And we just figured out that a to the negative 2 is the same thing as 1 over a to the exponent positive 2. Now, that 1 is really 1 over 1, and when I'm taking a fraction and dividing it by another fraction, I can really rewrite that as 1 over 1 times, I'm going to multiply by the reciprocal, which is a over 2, or a to the exponent of 2 over 1. And then multiplying fractions, the rule is multiply numerators together, so 1 times a squared will be a squared, and on the bottom I have 1 times 1, which is 1, so that in the end equals a squared. So it looks like if I have 1 over a to the negative 2, that negative exponent is going to tell me to take the reciprocal, or slide that base up to the top, and make the exponent positive. Okay, so let's look at this other example here. I have an a to the negative 2, an a divided by b to the exponent negative 2. Well, that really means the whole thing gets the exponent of negative 2. So the a is going to get a negative 2 as an exponent, and the b gets an exponent of negative 2. Now, let's rewrite that as a to the negative 2. With the line and 2 dots, I change that divide into the line and 2 dots, and I end up with b to the exponent negative 2 dividing the a to the exponent negative 2. Now what I'm going to do is change what I know. I know a to the exponent negative 2 should be the same as 1 over a squared, and that's going to be divided by b to the negative 2 should be 1 over b to the 2. And then I'm going to change that to multiply by the reciprocal. 1 over a squared becomes gets multiplied by b squared over 1. B squared over 1. A 1 times b squared on the top will be b squared, and a 1 times a squared on the bottom will be a squared. So in this case, it looks like a over b all to the negative 2 really becomes b squared over a squared, which is the same thing as b over a to the positive 2. So lots of 3 different examples here of negative exponents, but the big idea here is that when you have a negative exponent, it's going to switch its position. The base switches its position from numerator to denominator, or vice versa, and then the exponent becomes positive. So let me write that in here. So hopefully this rule makes sense. When the base has a negative exponent, you're going to switch the base's position. So if it's in the numerator, it goes down to the denominator, or vice versa. If it's in the denominator, it slides up to the numerator. And the sign of the exponent changes to positive. The sign of the base does not change. It's only the sign of the exponent that changes. Now, this negative exponent rule is complicated, and you really want to apply it very last. You don't want to apply it until you absolutely have to, because sometimes other rules will eliminate the need for it.